Okay, hello and welcome to the Studio 9 review. This is the final studio of the semester, and this week the topic that we'll be going over is maps. So let's go ahead and jump right on in. I've already loaded the repository up into Eclipse, and the first exercise here has to do with names and heights. They ask us to open this file, and then we want to create a new instance of a map. So this is an interface. We'll need to create an instance of a class which implements it, and if you clicked on this link, you can see that we're suggesting that you use hash map here. So if you did the prep work, then something like this should get the job done. Now, map equals new hash map. Now recall that when we see these angle brackets, right? That means that we need to include some types in there. And so for the purposes of this studio, we need to see that we're going to have a member of our team's name with their height. So inches or centimeters, depending on what you want. So that means that the keys, the team member's name, are likely going to be strings, and the values, inches, centimeters, could be integers or doubles, perhaps. If you want to get very accurate. So we need to indicate that when we construct our map as follows. So here I'll put string and integer. And if you want to make a little note to yourself, we need to make a name as well. There we go. If you want to make a little note to yourself, height in inches, right? Something like that. The next thing that it asks us to do is to put our team members' names into that map. So the two operations that are most commonly used on maps are put, when we associate a value with a key, and then get, where we ask the map to tell us what value we have with associated with a particular key. So that's what we're going to go ahead and start using here. I'm going to go ahead and just put in some heights. Height map.put, my name is Doug, and my height in inches is about 70 inches tall, perhaps. Height map.put, I'll put Franklin in here. Franklin's height in inches, I don't know, what do you all think? Let's see, Franklin looks like, we'll call that, maybe 3 feet across from head to tail? 36 inches? I have no idea how accurate that is. Long cat is long. Height map.put, let's see, my daughter's name is Pearl. And she's probably, I don't know, about 2.5 feet tall, so that'd be about 30 inches. She's shorter than my cat is long? Really? I don't know that I need to be thinking about that right now. Back to the task at hand. So we've gone ahead and associated these names with these values. The next thing that we're asked to do is to repeatedly prompt the user for a name. So if we cancel by typing quit, then we'll stop prompting for more names. So we're going to use scanner.in. For this purpose, we can go ahead and say system.out.println, please enter a name. Or maybe I'll just do print. It's a little cleaner, perhaps. And then I'll read in a name as a string in dot next line, right? Okay. Please enter a name. And then if I want to see what height is associated with that, that would be the opposite of a put operation on our map. We would use a get operation. So height map.get name should retrieve whatever that value is. So maybe we should stash that into a variable, an integer variable. Grab that out, and then we will print it. Excuse me. Name is height There we go. Let's give this a shot. Notice that this is probably just going to go through one time. I didn't actually code up the part where they keep prompting until it types quit. But let's just see if it works for the once. So please enter a name. If I type in my name, for example, Doug is 70 inches tall. That's good. If I type in Franklin's name, Franklin is 36 inches tall. That's good. What if I type in a name that doesn't exist? My son's name is Simon. I didn't put him in the map. Okay, here we go. Exception in thread main cannot invoke invalid. So it's null, right? Recall that if I try to fetch something from a map and I see that it is and the value is not in there, then that means that the value is going to be that means that it's going to give us a null value back. And actually, there's a little bit of a inconsistency here. You can see up top, I had a couple people ask me about this. This is an integer type up here, whereas down here I used int. So that's an interesting distinction. They actually both represent integers, as in whole values, whole numbers. But this is an object type, hence why it follows the traditional capitalization that represents object names, whereas this is what's called a primitive type. We learned about the primitive types way back in the first week of class. When using maps or linked lists or sets in Java, we actually can't use primitive types here. So it's not allowed. You can see that if I try, it doesn't let me do that. It needs to have an object type here, which is why this integer class exists. It's an object representation of the primitive type int. In fact, if I use that here, that will change the error message just a little bit that prints out when I type in a name that doesn't exist, like Simon. You can see it now says Simon is null inches tall, which is a little bit nicer, but still kind of a problem, right? Still kind of an issue to deal with. So we could, if we wanted to, stick an if statement in here and say something like if height is equal to null, not found, right? Else, we'll print out the user that we did find. So that should help fix that problem. Not found. There we go. Now let's talk about the issue where we need to keep repeating until we get the answer quit. That really depends on the name, right? That really depends on this name here. We don't know how many names they're going to try to type in. In fact, they could try to type in the same name multiple times if they wanted to. So we really need, I think, a while loop here to make this happen. And let's think about what we want to be inside of the while loop. I think really we need basically all of this stuff to be inside of our while loop. So I'll say something like while name dot equals quit. Notice that I use dot equals there instead of equals equals because I'm trying to compare strings, which are objects. If that doesn't make sense to you, why I said all of that, you might want to go back and review the Module 8 material where that's covered in more detail. You can see there's a problem here. It doesn't know what name is because name's declared inside. So let's fix that. Let's just declare name outside. So I'll say string name equals just an empty string to start. And now I think we should be good to go. Let's give this a try. Go ahead and run this code now. If I enter good names, it tells me that I'm 70 inches tall. Here's Franklin, 36 inches tall. That's all good. If I enter a bad name like Simon, it tells me that it's not found. And if I enter the word quit, uh-oh, I did it wrong. Well, actually, I didn't do it wrong. It did quit, right? It didn't find it, printed out not found, and then actually quit. I wonder how I would fix that. I guess you would have to... Oh, I don't know. You could also do the name equality check down here. That seems a little redundant, right? To have to do it twice? I'm not sure that I'm the biggest fan of that solution. But there's more than one way to figure this out. You could also, I think, maybe try to do something, you know, like say get or default, which if it can't find the value will return a default value instead. So you could use -1 here, right? Perhaps to represent the fact that you haven't found the value. That'll also eliminate this null check. It'll actually turn this check into, you know, if height equals -1, that means it wasn't found. Anyhow, I think you can kind of play around with this and tweak it until you've got it working just the way you want it to. I'm going to go ahead and move on to the next one. The next problem involves counting words. So we're going to construct a word count method, And this word count method, let me just go ahead and open the code because I think it's got everything we need already there. This word count method accepts a list of words, right? We need to go through this list of words and count how many times each word appears in this list. So by the end, I want to have a map that, you know, contains all of the words in this list and the number of times that each of those words appears. So the first thing that we need to do, you can see, is that we need distinct words as keys, each associated with the number of occurrences of the word. So let's go ahead and make our map again for starters. You can see string integers is going to be the way to go. Call it word count. We'll make it a hash map. Okay, and I want you to consider, we just saw in the previous example, right, that there's actually two cases that we need to consider here. Well, before I talk about that, let me go ahead and set up a little bit more of our framework here and just do iterate through our list, which I'm going to go ahead and do using an enhanced for loop or a for each loop, because that'll do for us. All right. So now that I've got this loop iterating through each of the words in the list, let's consider that what we need to do, we have two situations that can happen, right? If I plug the word into this map and it gives me back a value, I know that I've seen that word before, right? I've seen that word before, whatever that number of times is that I receive back from the map. So if that's the case, right, then all I need to do is increment that value by 1 and put it back into the map. If I plug the word into the map and it's a brand new word, I have not seen this word before, then the map is going to tell me null, right? It's going to return null. That's what maps give us if it can't find a key that's been stored in the map. So if that's the case, right, I know that I have seen that word one time, right? It's the first time that I'm seeing that word, so I can write that down. I can write down the fact that I've seen that word one time. So let's retrieve the value from the map and see if we can start to piece this together. I'm going to go ahead and try to fetch the integer out of this map, right? Or another, you could do this in a few different ways. You could say, yeah, so let me do it this way. There is more than one way to do this problem. You can see that I was actually just trying to decide in my head between 2 or 3 different ways that I wanted to potentially solve this problem. So if you came up with a different solution than what I'm about to go through, thumbs up. I think that's an absolutely fantastic thing. That is not a bad thing at all. So I'll go ahead and grab the count out of my word count map for starters, using the word from the list, right? Got an equal sign there. Okay, if that count is equal to null, that means we have not seen the word before, right? New word. Otherwise, update the count. In the case of a new word, we just know that we've seen that word one time, so I'll say word count dot put word 1. I've seen this word one time. Otherwise, I'm just going to go ahead and say word count dot put word count plus 1. Increment the count by 1 as I put it back into the map. This will replace the old value. Remember, if I insert a value into the map that already exists in the map, whatever value used to be associated with that key is simply replaced by the new value that is being given. I believe that'll do it if I go ahead and return word count. That should satisfy the method. Let's go ahead and run this test suite to see what's going on here. Oops, wrong menu. Sorry about that. There we go. All tests pass. Pretty straightforward one. I do see people tend to overcomplicate this one a little bit, right? The tricky part is probably this if statement. This is the part that I talked to people about the most with this problem, is this if statement, recognizing that we have to treat words differently depending on whether or not we've seen them before. But otherwise, I think a fairly straightforward method. Okay, I believe we have one problem left to go. So let's take a look at this university database problem. The first step that we have you do is, so this relies on a working implementation of the student class from assignment 7. I've gone ahead and already copied this before I started the video. So I already have a working implementation of a student class copied into Eclipse. So I'm going to go ahead and move down to step 2 and open the university database file and start taking a look at what's in there, right? So really what we're trying to do is develop a university database where we're using a map to associate accounts with students. So we're going to have account names associated with students. That's the idea here. We're going to declare our map as an instance variable. Following the instructions, we'll declare this as a private final map, string student. Does it give us a name? No, it does not. Okay. Students, I'll call it. The final keyword, remember, means that once this instance variable has been created, it cannot be changed. So what that means in the case of a map means that once I have created and initialized this map, I cannot create and initialize another map to use in its place. I can modify the map that I have created and initialized, but I cannot replace it with a new one, right? Is the basic idea behind this final keyword. So, we can talk about a little bit more about what that means, because the next step is that it asks us to implement the default constructor. So the default constructor, let me fix this import real quick before I go on. The default constructor, is always going to be the constructor with 0 parameters. If I can spell. Right? This is the default constructor. The role of the constructor is still the same, to make sure that all of our instance variables are initialized. So I have to initialize this map, which, since it is an object, means that I have to call a constructor. So I'm going to go ahead and do that. This.students equals new hash map. Remember, I'm using hash map now, which is a specific implementation of the map interface. I'll have to import that as well. There we go. And now this default constructor has completed its task of making sure all of these have been initialized. All right. We now have to complete the methods that have been provided here. You'll notice that actually a lot of these methods are pretty straightforward. So for the sake of this first one, add student, this is really just making sure that the student with this account name gets put into the map. So that's really going to be as simple and straightforward as students.put account name student. I am simply receiving the information that has been given to me and making sure that it makes it into my map. For getting the number of students that are in this database, we need to consider, all of the students are going to be stored inside of this map. So let's go ahead and see if there's a way that we can get the map to tell us how many things that it has. If I type students dot, you can see that it pops up a list of things that I can tell the map to do. And if I scroll down here, one of the things is the size. So let's go ahead and use that as our student count. Return students.size. That should tell us how many students are currently in our map. The lookup full name method. So we see that it gives us an account name. So we're going to look up the student from the map, and then we're going to use the get full name method from the student. If the student that we retrieve from the map is null, then we should return null as that student's name. Okay? So let's do, this is a two-part process. We first need to retrieve the student from the map that has that's associated with this account name. So let's do that first. Student s equals students.get account name. So that will retrieve the student from the map. If the student is not in there, s will be null, and I should then go ahead and return null as stated in the instructions. Otherwise, I need to return the full name of this student, which we can get by calling the full name method on the student object that we retrieved from the map. The way that we do that is by typing the name of the instance first, which is S, followed by a dot, followed by the name of the method that we wish to use, which is getFullName. We'll go ahead and return that, and I believe that this method is now finished. I think there's only one method left to go. Get total bear bucks. So we need to iterate through all of the students that are in the map and see how many bear bucks they have. Create a running sum. So we've seen this pattern many times before. Let's go ahead and create a double sum. Set it to 0, right? Iterating over the map can be potentially tricky. The prep work shows you a couple of different ways to do this. One that iterates over all of the keys, and one that can iterate over the entries. Actually, both of them will work here. It does not actually matter which one you use to get this problem done. So my general advice is to pick one and get really comfortable with it. You don't necessarily need to use both or need to know how to do both, but you need to know how to do one of them, absolutely. So let's go ahead and just do the one that iterates over all of the keys. The way that we do that is by accessing the key set through our map. So I'm going to go ahead and write a loop for string account in. So the name of our map is students, and if I want to retrieve all of the keys from our map, that is going to be the key set. This is going to be a set because we know that there can't be any duplicates, right? If I try to insert a duplicate value into my map, it actually doesn't show up twice. It just overwrites whatever value was in there already. So we know this is going to be a set. This for loop should work, right? I'm using a for each loop again, which is a good way to iterate through sets because sets are not ordered. We can't use a loop variable that iterates through all of the indices like we would for a list or an array. Now to get the bear bucks, I'll just go ahead and plug the account into the map, just like I did before. This time I don't have to worry about null. I know that this value is going to be in the map because I am iterating through the key set, right? I'm iterating through all of the keys. I know that this key is guaranteed to exist. Once I grab that student, I can retrieve their bear bucks by calling the getBearBucksBalance method. And what I really need to do is just add that onto my sum. So I believe that this should complete the method once I return the sum that I have computed. Let's run this test suite and see. There we go. Passes all of the tests. Again, there is another way that you can use to iterate through hash maps that was covered in the prep work. That would also work here. Don't have a problem if you decided to use that method instead of the way that I did it here. In fact, if you did any of these things differently than the way that I did it here, that's totally fine, but I do think the solutions I presented here are pretty clean and straightforward for the most part. So I hope that helps illustrate how maps are used. It's an extremely important data structure and one that you're certain to see many times as you learn more and more about computer science.